So the problems we're going to talk about here are 5 of the released multiple choice questions from the 2015 Keystone scoring sampler. So these problems appeared on the 2014 Keystone test, and now they've been released for us to look at them and practice them to get ready for what we're going to do in a few months. So first question here, we've got these two expressions, right? Pi times x and x squared. For which value of x is the value of pi x greater than the value of x squared? So when is this greater than this? So what I did here is I kind of kept everything organized in a little table. I realized that my answer was one of these 4 x's. So I made a column for those x's. And then I wanted to put these 4 x's in place of each of the x's in these expressions. So what I did was I did pi times -2, typed it into the calculator, got -6.28. I then did -2 squared. -2 times -2 is +4. Is pi x greater than x squared if x is -2? No way. That negative number is definitely less than +4. So I realized that that was not my answer. So we could rule out choice A. Similarly, with 0, I put 0 here. Pi times 0 is 0. 0 squared is 0. Is 0 greater than 0? No, they're equal to each other. It's not greater than, so I'm ruling that one out. Now when I put in 1.5, check out what happens. Pi times 1.5, type that into the calculator and you get 4.71. 1.5 squared gives you 2.25. Well, when I put 1.5 in place of this x right here, I got 4.71. When I put it in place of this x right here, I got 2.25. This number is definitely bigger than this number. That kind of indicates that this is going to be my answer. Part D, if you check that one, you put 9 here. Pi times 9 is 28. 9 squared is 81. So the only one where pi x is greater than x squared is when x is 1.5. Second problem here involves simplifying a square root. Now, this is something that we haven't done a lot recently. When you have a root with a number underneath it that can be broken down, that might allow you to pull some stuff out from the root. And so the mindset needs to be, I want a number under this root that I can actually do the square root of. So the numbers that you can do the square root of are your perfect squares, 1, 4, 9, 16, 25, and then on up. So can I rewrite 8 as a multiplication problem? It has to be a multiplication problem. It can't be addition, subtraction, division. Has to be multiplication. Can I rewrite 8 as a multiplication problem that involves one of those numbers? Well, sure, I can rewrite 8 as 4 times 2. Why is doing this beneficial with that 8? Well, now that there's a multiplication problem under the square root, we can actually break that up into the multiplication of 2 separate roots. And why is that beneficial? Well, now that I just have the square root of 4 times the square root of 2 after the 3 here, I can do the square root of 4. The square root of 4 is 2. So I can do the square root of 4. The square root goes away from this piece. I've done that square root, and I end up with 3 times 2 times square root of 2. These numbers are now both outside the root, so I can multiply them back together to get a 6. And then I can't break that 2 down anymore, so I'm going to have 6 square root of 2 as my final answer, and we're looking at choice A as the sequence that shows that. So the tricky thing would have to be, hey, this is the right answer, but these steps definitely aren't right. This simplification process is always going to involve breaking it up with multiplication, not breaking it up with addition. In number 3, it's one of these estimation questions, so they provide us with quite a bit of info. Ethan and his friends bought some stuff for lunch, and they bought 2 sandwiches, here's the price of each, 2 burgers, price of each, bowl of soup, there's the price, and 5 drinks, there's the price. Now, it does say something about the amount of tax that they paid was 8%, and then they paid a tip that was about twice the amount of tax that they paid. So we want to estimate what the number of dollars that they forked over for lunch, including tax and tip, actually was. Now, it does say estimate, so you'll see the work that I did up here. $5.29 is about $5. So how much did they spend on the 2 sandwiches? Well, about $10. $6.79 is practically $7. They bought 2 burgers, So 7 times 2, they spent about $14 on those, about $4 on that 1 cup of soup, and then about $1 for each drink. So 1 times 5, $5 on the drinks. So before the tip and the tax, how much did they pay? 10 plus 14 plus 4 plus 5. That's going to end up giving you about $33. Now take into account the tax and the tip. Well, the tax is 8%. They say the tip is about twice the tax, so that's about 16%. And so if you think about 8 plus 16, that's 24%. How do I figure out what 24% of 33 is? Well, I have to turn the 24% into a decimal, so I move the decimal over 2 spots. 0.24 times 33. 24% of 33 is about $8. So I paid $33 before tax and tip, about $8 after tax and tip. 33 plus 8 puts me up a little bit above 40. The only option that's a little bit above 40 is option C. 4 is kind of tough. They tell us that the difference of 2 polynomial expressions is shown below, but then check out what's in that first polynomial, this unknown letter W. And the question is, what is the value of W? So I thought, well, I'm going to try to actually subtract these 2 polynomials. And when you subtract polynomials, all you do is you distribute to get rid of your parentheses, and then you combine your like terms. So when I distribute 1 into this first set of parentheses, nothing changes. The set of parentheses just goes away. But when I distribute -1 into this second set of parentheses, I'm going to be looking at a negative 1x squared. -1 times positive 5 is negative 5 in front of the x, and then -1 times positive 6 is negative 6 at the end of that line. What normally happens when you're subtracting polynomials like we're doing right now is you have some like terms you can combine. So I noticed that this term here and this term here, the terms I've underlined in green, the x squared terms, -2 minus 1 gets me to -3 of those x squared terms. The terms in red, -4 minus 6 more gives me -10. Check out what the answer we're supposed to get is. The answer we're supposed to get is -3x squared plus 10. What pieces haven't I accounted for from this line right here in this line yet? Well, I haven't accounted for the pieces that I've underlined in pink. The wx and the -5x, what are those going to have to equal? Well, if there's no x term in this answer, the wx and the -5x, they must cancel out with each other. They must go to 0. So if wx minus 5x is going to be 0, doesn't this have to be 5x minus 5x to get to 0x? And that tells me that my value for w is going to have to be positive 5. And then the last question in the list for this week is a situation where someone has purchased 100 baseball cards to start a collection, purchases 25 more baseball cards each week. Which equation could be used to represent the number of baseball cards B in the collection after W weeks? So when I read this, what I realized right away was, hey, this is the beginning amount of baseball cards in the collection. This is the rate that he's changing that amount per week. He's adding 25 more cards to that collection every week. So I realized I had a beginning value and I had a rate. So I know that my slope-intercept form blueprint is going to be pretty easy to build here. And so I know that my rate is going to go in place of the m in place of the slope, and the beginning value is going to go in place of my b. So I put the 25, the rate that he's adding to the collection every week, in place of m. I put the beginning amount of cards in the collection in place of b, and I had y equals 25x plus 100. Okay, check out the answers. No x's and y's. I can rule out this choice. I can rule out this choice, right? The 100 is going to be added on at the end, and that's definitely what I see here in choice A. That's definitely what I see here in choice C. So I guess the issue is which variable, x or y, is going to get replaced with w, and which variable is going to get replaced with b. So what I did here is I took the approach of graphing to try to build that conclusion, because I realized that this graph was going to begin at 100 on the y-axis. I was going to have a rise of 25 and a run of 1. So I go up 25 over 1, put a point on my graph. So my x value is 1, my y value is 125. I go up 25 more, I run 1 more, so my new x is 2. I've now gone over 2 from where I began my graph, but I've gone up an additional 25. So now I'm up to 150. So which variable is really being plotted on the y-axis here, which variable is replacing the y. Well, this is going to be the amount of baseball cards that we have in the collection. Right, I started with 100. After 1 week, I'm up to 125. After 2 weeks, I'm up to 150. So I've got my B values on the y-axis, and the number of weeks that go by is what I have plotted on the x-axis. After 1 week, I've got 25 more cards in that collection. So I guess we've decided that B is replacing y, W is replacing x. So if I put a B here and a W here, B in place of y, W in place of x, I'm looking at choice C.